You are welcome once again to IGCSE Chemistry Online Notebooks. This is a continuation of the Unit 6 of the IGCSE syllabus, and we want to consider today factors affecting the rate of chemical reactions. In the syllabus, the learning objective is that you should be able to describe and explain the effect of concentration, surface area, catalyst, and temperature on the rate of chemical reaction. So, we have to consider them one after the other. Number one, changing the concentration of solution. Number two, changing the pressure of gases. Number three, changing the surface area of solids. Number four, adding or removing catalysts, including enzymes. Number five, changing the temperature of the reacting mixtures. But before we go in depth into factors affecting rate of chemical reaction, there is a theory we need to quickly understand, or we need to quickly master, and that is collision theory. And collision theory is very important when it comes to IGCSE syllabus as regards the topic under consideration. You are to use collision theory to explain how temperature, concentration, pressure, catalyst, and surface area affect the rate of chemical reaction. If particles are to react together in a given chemical reaction, such particles must possess sufficient amount of energy to do so. For example, looking at particles of substance A and the particles of reactant B, for the two of these reactants, A and B, to react together to form a new product C, there must be sufficient amount of energy that must be possessed by the reacting particles. And this energy is called the activation energy. When A and B particles collide to form a new product C, then the collision is said to be a successful collision. If A and B are able to successfully collide to form new product C, then that collision is said to be a successful collision. Not all collisions are successful, and so we have successful collision and unsuccessful collision. In a case where A and B collide but do not bring about the formation of C, then the collision is said to be an unsuccessful collision. So, for collision between reacting particles to be successful, the particles must, number one, possess sufficient amount of energy. Number two, possess sufficient frequency of collision. Now the question is, what is activation energy? Pause a while and write your answer and see if from what we have discussed now, you are able to define activation energy. How changing concentration of solution affects the rate of chemical reaction. There is an example here. Two beaker A and B. Beaker A contains 25 centimeter cube of aqueous hydrochloric acid, and beaker B also contains 25 centimeter cube of aqueous hydrochloric acid. We've seen the water particles and the hydrochloric acid particles in A and B. Now, these two acids in A and B are to react with 5 grams of calcium carbonate lump. Which solution will consume the calcium carbonate faster? Which beaker will give a faster reaction with 5 grams of calcium carbonate? Now, in beaker A, there are less particles of acid per unit volume. Just like you can see, 20 centimeter cube of water in beaker A, 5 centimeter cube of hydrochloric acid. So there is lesser amount of acid particles in beaker A. So the collision between the particles of acid and particles of calcium carbonate is less frequent. Hence, there will be a low rate of reaction. Then in beaker B, 10 centimeter cube of water as against 15 centimeter cube of hydrochloric acid. And so in beaker B, we have more particles of acid per unit volume. So in beaker B, there are more particles of acid per unit volume. So the collision between the particles of acid and particles of calcium carbonate is more frequent. Hence, there will be an increase in the rate of reaction in beaker B. In conclusion, the higher the concentration of reacting particles, the higher the frequency of collision, and the higher the rate of chemical reaction. Now, think of this question here. What happens to the rate of chemical reaction when the concentration of the reacting particles decreases? Thank you.